Hello, everyone. So our next speaker is Andrew T. Baker, and his talk is called Demystifying Docker. Please give him a warm welcome.
Great, thank you. Docker is a really interesting technology, and there's a lot to it, way more than we can discuss in 25 minutes. But my goal today is to kind of give you enough to understand the basics and sort of demystify anything that might have been confusing you about Docker, and then kind of give you an appetite to go and try it out yourself. So first, a little bit about me. My name is Andrew Baker. I'm a software developer in Washington, D.C. I'm currently independent. I did consulting for most of my career, and then I took some time off last fall to work on my own projects. And one of those was an introduction to Docker video tutorial with O'Reilly, which is kind of like a 2-hour crash course to get you started with Docker, and is available on their Safari service if your company subscribes to that. So I don't work for Docker, but I've been using Docker for about 1.5 years, and I think it's really, really interesting technology. And it turns out lots of people in this world want to know about Docker, and I really like teaching people, so it's a good match for both of us. Now let's talk a little bit about you. So who here has done the official Docker tutorial on Docker's website? Okay, maybe a quarter of the room. Who has installed Docker on their machine? Okay, and who has written a Docker file for their own application? Okay, yeah, pretty good. About a quarter all the way across the board. So I think we were definitely in the sweet spot for this talk. So today we're going to talk about what is Docker exactly. We're going to go through some sample workflows of how you deploy applications with and without Docker. We're going to kind of talk about the story of Docker, where it came from and where it's going. And then I'm going to wrap up with 5 tips that you should know before you try out Docker for yourself. So who here has said this phrase to one of their coworkers before? I would imagine most hands in the room would go up if your coworkers were not sitting next to you and you're still bitter about that, that production defect. So this is one of the worst parts about being a software developer, when something goes wrong because of an environment mismatch. And even when it's 2 good engineers who are trying to solve the problem, you're both human beings. And so in the back of your heads, you're thinking, who is to blame for this production level defect that has management breathing down my neck now? So I think Docker is an interesting technology for lots of reasons, but for me as a software developer, this is the most compelling reason to use Docker, because it helps me solve this particular problem of making all of my environments much more consistent. So the promise of Docker, you might have seen before, is build once, run anywhere. The central concept in Docker is this idea of a software container. And when you have this container on your development machine, you as a developer can wire up everything inside that container exactly the way you want. So you can install your operating system level dependencies, like which version of Python you want. You can install your Python dependencies. You can install your application source code. And then once you kind of seal up that box, wherever it goes, whether it's another developer's machine, a server in your office, a server in the cloud, it's going to behave the exact same way. And I can say that in my 1.5 years of experience using Docker and deploying to different environments, that this promise pretty much holds true. So what is Docker exactly? When most people hear about Docker for the first time, they try and compare it to an existing tool that they already use. So some people think it's like a virtualization tool like VMware or VirtualBox. Some people might think it's a VM manager like Vagrant. Some people compare it to configuration management tools like Chef or Ansible. Or maybe you've heard phrases like cgroups, LXC, libvirt, or Go. The truth is that Docker is kind of in a category unto itself. There's not really anything out there that's quite like it. And if you go to docker.com's website and you ask them what Docker is, they will tell you Docker is an open application for developers and sysadmins to build, ship, and run distributed applications. Which helps. I know that it's about developers and sysadmins, and I know it's about running software, but it still doesn't really quite paint the whole picture. For me, I like to think of Docker as occupying a spot on a spectrum. So this is a spectrum of techniques for deploying a software application to a server. All the way on the left side of the spectrum are techniques that are less portable but have minimal overhead. And the epitome of this end of the spectrum is manual configuration. This is when you spin up a new EC2 instance in the cloud, or a new server comes in the mail to your office and you unbox it and boot it up. You have to get access to that server, run all the commands in the right sequence to configure your application, all of its dependencies, all the operating system level dependencies. And then when you're done, your application is ready to go to production and flip the big switch. This technique is great, it's straightforward, it's probably how all of us configured our first server, but it suffers from a lack of reproducibility. When you spin up that next server, you have to run all the same commands, and if you're human, you're probably error prone, and you're liable to make a mistake. So the conventional solution to this problem for the past 10 years has been configuration management tools like Chef, Puppet, Ansible, Salt. These tools, when you're using these tools, you define a desired end state for your server using their specific configuration language. And then when you point those tools at a new server, they go off and configure everything for you. And so these tools are great because it means once we've done the work to configure one server, it's much easier for us to take that work and apply it to subsequent servers. But they all have the catch of you have to learn their specific technology. You have to know how to write a Puppet file or an Ansible playbook to make them work. And when you spin up a new server, you still have to wait for that configuration management tool to run and do all of its work before you can actually get in there and use it. All the way on the right side of the spectrum are techniques that are most portable but have lots of overhead. And this is where traditional virtual machines lie. So if you work at a company right now where your build process creates an Amazon machine image at the end of your build workflow, then you take that Amazon machine image, which is a full virtual machine image, and deploy it to EC2. And virtual machines are great because you know that wherever they run, they are going to behave the exact same way because they think that they are a full, real computer. They're completely isolated from their host operating system. But they're also really cumbersome. The virtual machine's disk image size is the same disk image that you would need if you were installing a server on a hard drive in your office. It's big. And they take a long time to boot up, and they take more time to boot up the more services you have running on them. So to me, Docker occupies a sweet spot on the spectrum, where you get most of the benefits of portability and isolation of traditional virtual machines, but at a fraction of the overhead. Docker containers are much, much smaller, have a much smaller footprint than traditional virtual machines, and they start up in the blink of an eye, which has benefits beyond even just solving problems for impatient people like me, but it also opens up really interesting new possibilities for how you can spin up applications. So how exactly does Docker pull this off? We don't have time today to go into the full details of how Docker manages to do this kind of container virtualization. But if you've been to docker.com before, you've probably seen a diagram like this. This is how traditional virtual machines work, where you have server hardware at the bottom, a host operating system above that, and then there's a hypervisor layer like VirtualBox or VMware, which is using the computing power of your server to provide virtual hardware that is then consumed by a guest operating system. And that guest operating system is where you, as the developer, install all of the dependencies for your application. So great for isolation, but redundant operating systems. We're running a host operating system and a guest operating system. With Docker, the stack looks a lot shorter. We still have our server hardware and our host operating system on the bottom, but instead of the hypervisor layer, we have the Docker engine. And the Docker engine is essentially relying on some other open source tools to create these software containers, which are in essence smart enough to leverage the components of the host operating system to create what looks like a fully isolated virtual guest operating system for the applications that you run inside it. So, like I said, we don't have time to go into the full details today, but they're definitely out there. But I actually think one of the really cool things about Docker is that it wasn't the first open source project to deal with software containers, but it was the first to make it accessible to people who aren't Linux experts. And if you needed to be a Linux expert to use Docker, then I definitely would not be standing here before you today. So now I want to walk through a couple workflows of how you might deploy a typical software application. First using just traditional workflow, maybe with a configuration management tool, and then using Docker containers. So to kind of set the scene, we have 3 different environments. Our application is a Django web application. You can see the little DJ in the circle there. And it uses a Postgres database on the back end, and it's served up on the front end with Nginx for reverse proxy. And we use a small Redis server as a cache. So on a developer's machine, all the way on the left, they're probably developing using the Django development server, manage.py run server. And hopefully, if they're following some good 2-scoops advice, they're running real Postgres on their server instead of just using SQLite. And then all the way on production is where we have all the components in our stack. And that might be the first time in our workflow that we see all those components in play. So let's walk through how a code update would propagate through this workflow. First, a developer writes some new code, looks good, commits it, pushes it up to our Git server, and the master branch on our Git repository, atbaker/myproject, now points to the most recent commit that the developer just pushed up. After that, our build server leaps into action, pulls down that latest code, runs our test suite, and then if the build passes, we put a nice little green dot on that commit saying that everything's cool. Or if it's on a pull request, we say the pull request is good to merge. One thing that's already kind of tricky about this situation is that you might not unless you're very careful, you might not have the same version of Postgres running in both of those environments. And this is especially tricky if you are using a outsourced continuous integration service like Travis or Circle CI. I noticed when Postgres 9.4 came out, it wasn't exactly immediate that Travis and Circle added full support for 9.4. So if you had a new developer rolling onto your project who set up their development machine for the first time, they probably would have ended up with 9.4 unless you went out of your way to tell them that we're still on 9.3. So after the build server says that everything looks good, then we go ahead and take that new code into production. And we might use a configuration management tool, or if we're keeping things simple, then someone would SSH into our production servers, our database server or our application server, and deploy that new code and restart all the services necessary. So in this diagram, each circle is a process that's running in each environment. With Docker, the workflow looks a little bit different. You'll notice right off the bat that we've got a new box in the top right corner called the Docker registry. We'll see how that fits in a second. And you'll also notice that on our development machine, we're running all 4 components of our stack. And we're not just running those little white circle processes right on our native machine, we're running them inside Docker containers. So we have a box, a Docker container for each process in our stack. And that's sort of a rule of thumb when you start working with Docker is 1 process per container. So let's see how our workflow looks a little bit different now that we're using Docker. When we have new code, our developer would still push it up to GitHub. That's just the same. Our Git repo would update with the latest commits on our master branch. Our build server would leap into action and pull down that latest code. But then when it finishes the build, it's still going to probably put that green dot back to GitHub to let everybody know that everything's OK. But it's also going to produce something new. It's going to produce something called a Docker image. And it's going to push that Docker image up to the Docker registry. That could be the Docker Hub, which is the Docker registry that Docker Incorporated maintains, or it could be your own internal Docker registry that you've stood up yourself. This Docker image represents not just a snapshot of your code at a point in time, like a git commit does, but also a snapshot of the entire environment that that application was tested in. And so that is the artifact that you can be confident will behave the exact same way in production as it did on your build server. So now when we go to deploy to production, we'll see that, again, all of our processes are running inside containers. And instead of reaching out to our Git server to pull down our latest code, we're reaching out to the Docker registry to pull down the latest full good image of our code and the environment it ran in. And we are going to spawn a new container in that production environment based on that Docker image. So this could be a little confusing, and like I said, the best way to get your feet wet is just jumping into it and trying it out yourself. But one point I want to stress before we go any further is the difference between containers and images. This is by far the thing that is the most difficult to learn when you start working with Docker for the first time. And sort of the rule of thumb to remember is that containers are how you run your application. It's the only way any work gets done in the Docker world. Images are how you store your application and how you move your application, move those kind of fully baked, safe, isolated environments between different servers. So on this previous slide, all these boxes are containers. In our development machine, we're running a container for each process. On the build server, we're running a container for each process. In production, we are running a container for each process. But the Docker image is how we propagate new changes between all those environments. So when you start working with Docker yourself, the first thing you need to do before you can take an application and put it inside a Docker container is to create a Docker file for it. A Docker file is a special file that lives alongside your source code, which basically tells Docker how to create a Docker image for your software application. And when you look at the commands here, even though you may have never seen a Docker file before, it's actually pretty easy to interpret. Some people have described them as almost glorified bash scripts with a couple extra special commands. So all the way at the top, each Docker image has to start from a base image. And in this case, our base image is just a plain, kind of stripped down installation of the Ubuntu Linux distribution. After that, we run 3 commands to install MongoDB in this example. And then we tell Docker which port is the relevant port that it should expose from containers that are created from this image. And we tell Docker what command it should run by default when it creates new containers from this image. Now, one of the really, really cool things, and maybe my favorite thing about Docker, is that you don't actually have to start from Ubuntu, from a raw Linux distribution when you're creating your own Docker images. there's actually this really awesome thing called the Docker library, which is a collection of official images maintained by Docker and other open source projects for almost every kind of programming language or server appliance you can imagine. So there's one for Python, there's one for Ruby, Java, PHP. There's also ones for Postgres, MySQL, Redis, Memcached, Nginx, Apache, and there's more and more being added all the time. These Docker library images provide to you a base image that already has Python installed in this example. So you don't have to worry about installing Python. You just tell Docker, I want to build my images from the Python 3.4 image. And when you start configuring your own application with inside that container, it already has Python 3.4 installed for you. One of the really cool things about these base images is that they actually have some extra special sauce, which are called the on-build images. And these images come with some extra commands built into them to help you configure your application. So when you use the Python 3-on-build base image, you can go from 0 to Docker on a software application in 2 lines of code, because Docker will look for a requirements.txt file in your repository, copy it into the container, install your requirements, then look for your source code in the directory that's alongside your Docker file, copy all that into the container, and you're ready to go. All you have to do is specify the base image, that on-build base image, and the default command that Docker should run when it creates new containers from that image. Okay, so now I want to shift gears a little bit and kind of talk about the story of Docker, because I think it's a really cool story and it's especially relevant for this audience. So Docker has familiar origins. Believe it or not, it was actually revealed at PyCon, at this very conference 2 years ago in 2013. Solomon Hykes, who was the founder of DocCloud, did a lightning talk, which you can still see on PyVideo, and I recommend going back and checking it out because it's pretty cool to see, where he talks about how DocCloud runs a platform as a service business. DocCloud was a company that was often mentioned in the same breath as Heroku. And often people would come to DocCloud and say, how can I do the kind of crazy stuff that you guys do to run a platform as a service? And for a long time, they said, it's really complicated. You have to use Linux containers. And eventually, they created this open source project called Docker to make it accessible for people like us. And after that, everything is history. Docker kind of caught fire and became one of the hottest open source projects from last year. At the end of 2013, DocCloud officially changed its name to Docker and rebuilt its whole business around the open source project that is Docker. And it actually spun off its platform as a service business to another company. So since then, tons of open source projects have been created using Docker. An obvious application early on was using Docker to run a platform as a service, because that's what it did at DocCloud. And if you look at projects like Doku or Flynn or Deus, those are really good options if you want to stand up a platform as a service within your own company. Another cool story is the story of Fig, which is an open source project built on top of Docker that made it easier to run multiple Docker containers at once, and made it easier to stand up that whole development stack of your application server, Nginx, your cache, your database. Fig was so successful that it was actually acquired by Docker and is now being rebranded as an official Docker tool called Docker Compose. But there's lots more you can do with Docker. There are new continuous integration servers being built with Docker, all sorts of crazy stuff. One of my favorite applications of Docker is eliminating some of the hassle of using dependency-heavy utilities. So on Wednesday morning, I ran a 3-hour tutorial on Docker here at PyCon, and at the end of the first exercise, students created a GIF using a Docker image. I found this command line utility when I was looking to make a GIF for myself a few weeks ago, and it looked really, really good, but it was a node tool, and not only was it a node tool, but it also had 3 additional system-level dependencies that I would have had to install after I installed this particular package. I would have had to install ffmpeg, I would have had to install convert, which was a binary that's some part of ImageMagick, and I would have had to install some fork of another repository. But I was so pleased to see right under the list of requirements, or you can just use this Docker image that someone out there has already created for you. So it took the process of making a GIF using this tool from installing Node, installing all of these packages, to running one command with Docker, pointing that container to my movie file, and then outputting the GIF, and I'm ready to go. So starting to look forward a little bit, in 2014, Docker's priorities were get to 1.0, production ready, take that big red notices off the documentation, which says use at your own risk. That happened last summer. Establish partnerships throughout the industry so that it's easier for you to use Docker with existing components in your stack. And also round out some rough edges that made it harder for newcomers to start using Docker. So in 2015, it seems like Docker's priorities are making Docker easier to use all around, continuing to round out some of those rough edges that make it hard for people who are new to Docker to get started with it. Popularized best practices for scaling. This is what I'm most interested in as someone who's been using Docker for some time now. When Docker hit 1.0 last June, it's been about, I guess, 9 months, almost a year, since that happened. And so big companies are starting to use Docker in production for serious things. And we are all very excited to hear them come back with some more stories about how they've done it. And we're also, I'm sure, going to see lots of new open source projects pop up of tools that people use to help them do this. So it's going to be really exciting to see how Docker kind of breaks out this year and has really great stories about how people are using it at scale. Docker this year is also trying to include more batteries. So Docker is adding 3 new tools to its official stack, called Docker Compose, which I mentioned earlier, that previously known as Fig, Docker Machine, and Docker Swarm. And essentially, these 3 tools are going to help you as the developer go from 0 to Dockerized application to your own Docker cluster across multiple hosts in the cloud without having to reach out to any third-party tools. So Docker is definitely not trying to cannibalize the ecosystem of other more mature third-party tools that are out there to help you run your cluster of Docker containers in the cloud. But they're trying to give you, the developer, all the tools you need to at least get started on your own, which I think is a really great idea. So now I want to wrap up with 5 tips on how you can try out Docker for yourself. First, when you're trying to pick a component of your business to try out using Docker, I would try to go all in on a non-essential service. And what I mean by that is don't just use Docker for your development environments. If you have a really, really complicated development environment with lots of moving parts, then Docker could still be useful to you. But one of the catches, one of the strange things about Docker is that all the work you do to Dockerize an application and to get your stack working locally is also 90% of the same work you need to do to take those containers out to the cloud. And so it can be frustrating when you're new to Docker if you're spending all of this work just making Docker work on your development machine, but you don't get to see that payoff of seeing how easily you can move your whole stack consistently to other environments. 2, make sure you use those official base images like I talked about. But like you saw in that Docker file for MongoDB, it's pretty easy to build your own Docker files if you need them. So don't be afraid to discard those official images when they can't do exactly what you're looking to do. And the cool thing about the official images is that they're all open source, so you can see all of the Docker files that were used to create those official base images, which I often do when I'm trying to reference Docker file best practices. 3, install Docker Compose right after you install Docker. Docker Compose, formerly known as Fig, is really, really essential for running a realistic development environment on your development machine. It is the only way, pretty much, that I run more than one Docker container linked to each other on my development machine. I will use the regular Docker run command, the regular Docker command line client to kind of run one-off containers when I need them. But for the most part, when I'm working as a developer and I'm using my Docker stack, I'm using Docker Compose. So don't overlook this one. 4, keep an eye on Docker Machine and Docker Swarm. Those are those other 2 new batteries that I mentioned Docker is including this year. And number 5, if you're looking to dig in real soon, you can check out all the materials from my tutorial that we went through on Wednesday morning. One of the really cool and exciting things about Docker is that it moves really quick as an open source project, but one of the drawbacks of that is that a lot of the tutorials that might be high on your Google results are a little bit out of date and don't have the best practices. So I don't know how long this one's going to have a shelf life, but hopefully you can at least use it for the next month. And that's all I have.
So we have a few minutes for questions. If you've got one, please come to the microphone right there.
Hi, thanks for the talk. Quick question, going back to your build workflow. Basically, you've got it set up such that every time you do a release build, you're also rebuilding your Docker image from scratch. And if you go and look at your Docker file, that involves taking a base version of Ubuntu, running apt-get, which potentially pulls in bug fixes and changes from the underlying Ubuntu OS distribution. One can easily imagine situations where when you're deploying a new version of your app, you don't want to pick up changes to MongoDB until you have a chance to vet them independently, and vice versa. A lot of times you want to get bug fixes for underlying OS issues without having to redeploy a new version of your app. What are best practices for managing the changes in those dependencies independently?
Sure thing. So I didn't go into it in great detail here, but one of the great things about all those base images and all the official images that Docker maintains is that they all have liberal use of tags on those repositories. And those tags normally correspond to exact bug fix point versions for each of those appliances and programming languages. So that's the best place you should start to make sure that you know exactly what you're getting every time you're building your Docker images. And I've been pretty satisfied when they're, when there are new like bug fixes, new releases, new bug fix releases and minor releases of those programming languages and appliances, that those changes show up pretty quickly in those official repositories. So for me, that's been sufficient.
All right, thank you.
Yep.
Hey, so looking for some guidance as far as best practices. I have an app that's using Nginx to talk to Django via MicroWhiskey with over a Unix socket. And so I'm thinking of putting Nginx in one container and MicroWhiskey and Django in another container. And as far as sharing that Unix socket, should I use a volume that's shared between the containers, or should I scrap that entirely and use TCP to go between Nginx and MicroWhiskey and live with any performance differences?
Yeah, that's a great question. It seems like the practice that most people are using with Docker is doing links between containers using TCP. But I'm sure I've read something on the internet which shows you how to do it if you want to stick with the sockets. So I think you've got some options.
Okay, cool. Thank you.
Yeah.
Could you talk a little bit more about the distinction between an image and a container? So you were saying you run one process per container, but am I understanding correctly that an image would actually specify multiple processes and multiple containers described in one image? Is that right?
That's not quite right.
Okay.
So with each image you're building, if you're adhering to that best practice, each image you build will have one process that you intend to run in it.
So then the entire dependencies of an application would be multiple images?
Yes. When I am working on, when I'm working on a Django app that I'm using Docker for, I generally will use the official base images for Redis and Postgres because I'm not trying to do any customation on those. But for something like Nginx, where I want to plug in my own configuration file, I'm going to write my own Docker file just to drop that configuration file in. That's its own separate repository. So you do want to create a Docker file and an image for each element of your stack that you want to customize using Docker.
Okay, thank you.
Yeah, hope that helps.
Hey Andrew, my name's Luke Swart. I was thinking earlier, you mentioned that you want to have one container per process. It's a common Docker philosophy, but what do you recommend about running services with containers? Do you want to run them inside the container or outside the container, such as like a basic service like Keep Alive?
Yeah, that's definitely been one of the most interesting things to watch in the community as Docker has evolved. When Docker first came out, there was a very popular base image created by the people who do the Fusion Passenger project, which sort of made it easier to run multiple processes within a single container. And that base image is still out there, and it seems like people are still using it, but it seems like the conventional wisdom is you don't need process managers or services inside your containers. You should build it to run in a non-demonized mode, whatever process you're trying to run inside that one container.
Okay, thanks.
Yeah.
Hi, this is going to be a fairly newbie-ish question, but does Docker have any support for development and or deployment on Windows?
Yes, definitely not a bad question. So it was really funny last year seeing every week it seemed like there was a new big player in tech that was announcing that they wanted to partner with Docker. And Microsoft definitely didn't want to be left behind. From what I can tell, Microsoft is working on figuring out how to create their own sort of container technology that would be available in Docker, but it would be it would not be a situation where you could run a Windows container on a Linux machine or a Linux container on a Windows machine. It would essentially be two separate container implementations, and it's just they use the same API that Docker provides to do it in both environments.
Thank you.
Yeah, so it's definitely something to watch. And that's all the time we have. So thank you. So I'll be hanging out up here if you have any more questions, and thanks for coming by.